All right, students. Hi. Welcome to Sheep Eyeball Dissection 101. So I'm here in my gear. I've got my gloves on, my safety goggles, my lab coat. We are going to be dissecting a sheep eyeball today. I got plenty. So what we're going to do is I'm going to take one of these things out and I'm going to set it in our tray and we're going to walk through the parts about an eyeball.
Can you see me?
That's my son. He's dissecting too. We're going to walk through how the eye works in terms of light and color. So let me just adjust my camera so we can see my tray here. Let's get some light. Okay. So what I'm going to do is I'm going to take out our eyeball. Okay.
I want to touch it.
Lovely. All right, we're going to get this guy right there. Okay. So we have an eyeball. It's a ripe one. Okay. So the main thing about eyes is this allows us to see. Now, humans, I know this is a sheep eyeball, but humans can only see a narrow band of the electromagnetic spectrum, which holds our light rays. And the one that we can see is called the visible light spectrum. Now, humans see light as different colors of the visible light spectrum. So we see them as our rainbow. Now, the reason why we can see is because of the wavelength of light hits an object and then gets reflected off of that object and back into our eyes. That creates an image that we can see. This is very similar to how movie projectors work, where the light is projected from behind you, hits a screen, and then it bounces back or reflected off of the screen and into our eyes, and that's how we can see. So basically, the reason why we can see is because of light being reflected off of things. Okay, so we're going to examine this eyeball before we even actually cut into it. So we have a eye here. It's a little cloudy. Okay, thank you, buddy. So we have a lot of muscle around our eyeball. This is called the sclera, the tough outer covering that kind of goes over the eyeball. We have the cornea, which is in here. Okay. And then we have the pupil, which is the dark oval in the middle. We also have the iris, which is where we get our color of our eye from. This one, I believe, was brown. Okay. So what we're going to do is we are going to cut away our fat and muscle. So sheep eyes have this muscle here that allows the sheep to turn its eye left and right and up and down. Humans actually have one more muscle that allows us to kind of rotate our eye more freely. Okay, so we're just gonna cut away the fat here.
I say eyeballs are fun if you want to.
All right, Landon, if you're gonna be watching this, then you need to be quiet.
If I want to watch wrestling.
Then go get your father.
Okay.
Okay, so we're just gonna cut away. We're gonna cut away all that fat. Okay. All right. So we have our eyeball. All right. Okay. So now what we're going to do is we're actually going to make an excision in our cornea and release a liquid called the aqueous humor. Okay. So I'm just going to do a little incision here. Okay. It's a little tougher than I thought here. Okay. Okay. So we got a little bit of fluid coming out. That is called aqueous humor. It's actually what gives our eyeballs the shape of the round. So it kind of gives us our round shape. All right. So now we're going to actually cut through the sclera in the middle of the eye and separate our cornea and our lens from the back of our eyeball. So I'm just going to make an incision here, and we're basically just going to cut our eyeball in half. Okay, you can see more fluid coming out. That is our aqueous humor. Okay. All right, so now we have two parts to our eye. We have this part, which is the back of the eye, and this is actually the lens. And then we have this part here, which is our cornea, which contains our iris and our pupil. So what we have here is the cornea is made out of plenty of tough stuff because it helps protect your eye. It also helps you to see by bending, or we call that refracting light, as it enters your eye, and it changes angles. That's what refraction means. It means bending to change angle because it goes through a different medium. So it changes the angle of the light coming into your eye and bends it into the light receptors in the back of your eye. So the cornea is acting like the outer lens of a telescope, where it actually refracts the light and bends it in toward your eye. Okay? So what we're going to do is we're going to actually pull out the iris. Now the iris is the piece that gives your eye color. Sheep can only have one color, brown, but humans can have brown, green, blue, hazel, different colors. So the iris pulls right off. Okay. So the iris comes right off, and here it is. Okay. So this is the iris. This is the coloring of your eye, and the iris is actually a muscle. So it actually contracts and refracts as the light comes in. The hole that you see, this is the pupil. So the pupil, you would know, is the little black dot in your eye, is actually a hole that lets light in to your eye. So the pupil, the light comes in, and if there is a lot of light, the pupil shuts down and only lets a little bit in. But if there's dim light, it opens up big so it can let in all the possible light that we can, so you can see better in the dark. Now, again, remember, humans can only see a narrow band of the electromagnetic spectrum called the visible light spectrum. So the light that we see from the visible light is the only light that can actually enter our eyes and that we can detect. Okay? So that's the iris and the pupil. Okay. The next thing we're going to look at, I'm going to move my cornea and the iris over here, is we're going to look into the back part of the eye. So, that's the lens. So in the back part, we have this vitreous humor. The vitreous humor is this clear jelly-like substance, okay? So this clear jelly-like substance, which I'm going to peel it off of the lens here, it's clear or transparent, okay? Here is our vitreous humor, okay? So it's kind of like it's a jelly, and we can see that it's clear, and we call that transparent. And the reason why it's clear or transparent is so that light can pass through it. We call this transmission. So the light passes through this, so it can easily come through our pupil and through our lens to go to the back of the eye. So this is called transmission of light, where the light can pass through it. So you can see that you can actually see through it. Here it is. Okay, so that's the vitreous humor. So then, once we removed our vitreous humor here, we have the lens, okay? Now, I wish you guys were feeling this with me, because this is actually, it's a really hard little lumpy thing, okay? So this lens feels soft on the outside and hard in the middle, okay? That's because it's kind of like what we use for our telescopes and for our microscopes. It's a piece that likes to focus light. So this lens is a convex lens, and it helps focuses light toward the center of the lens. Okay. I don't know if this will work, I can try to bring it close Yeah, the camera's bad on these, but if you look through it, you can actually see through it, and it actually magnifies different things on paper. That's because a lens actually bends the light inward and creates a virtual image. And that's what gives our brain information from the light that we take in. So this is the lens. Okay. So I'm going to put the lens over there. All right, moving right along. Okay, so now that we've removed the vitreous humor, remember that's this clear jelly goopy thing. We've removed the lens, okay, which is this little hard round piece. We've removed the iris with the pupil. We've removed the cornea, which acts as kind of like a first lens that refracts our light in. Now we have this empty shell of an eyeball, okay? So we're going to empty this out, and you will see that we have this little stringy little muscle piece, and I think I actually just ripped it out, but let's see. Okay. So this little piece, it's kind of all goopy on my hand right here. This little piece is our retina. Now the retina, this one was kind of deteriorating a little bit. Let's see if I can get any more of it. Okay. So the retina, which is attached to the back of your eye, our retina is what detects light and color. So our retina, which in this eyeball is kind of all falling apart here, okay, but this is the retina. So the retina actually has rods and cones. Rods detect light. So if somebody is legally blind, that means they have a defect in this rod, meaning they cannot detect light. So rods detect light and cones detect color. Now in humans have 3 cones. We have a red, green, and blue cone to detect red, green, and blue light. If you remember, those are the 3 colors, the 3 primary colors of light. So with these 3 colors, we can actually detect all the other colors of the rainbow. So these cones are the ones that collect the wavelengths of light, and we see this visible light as the different colors of the rainbow. So we detect the different wavelengths and we put them in as different colors. Now, if somebody was colorblind, or if you were colorblind, then you would have a defect in one of those cones, either the red, the green, or the blue, and you would have some sort of color deficiency to where you wouldn't be able to see all the colors of visible light, which we see as the rainbow. So that's in the retina, okay? Now, what's really cool, get the retina off my finger, what's really cool about a sheep eye is in the back of the sheep eye, they have what's called a tapetum. This tapetum, and I'm trying to show you guys, has like this really cool iridescent look. I hope you guys can see that. So this iridescent look is what gives cows, sheep, cats, dogs, spiders the ability for their eyes to glow in the dark. So if you've ever looked out and it's in the dark and you see like cat's eyes glowing and they seem to glow, that's because this tapetum actually reflects light. So when the light comes in, whatever light is not collected by the retina is actually reflected back out to the outside world, which is what makes the eye seem like it's glowing. Now, humans, we don't have this. So if we had a human eyeball, the back of our eyeball would just be completely black. The reason why our eyes are black, it's black and a little bit of rough, that's because black and roughness are the best for absorbing light. So in our eye, whatever light is not detected into the retina, it gets absorbed by the back of our eyeball. Okay? All right, so now we're actually going to look a little bit closer at the back of the eyeball and see if we can find the optic nerve. Okay, so the optic nerve, take off the tapetum. Okay, the optic nerve is where your retina is connected to our brain. So once our light comes into the optic nerve or into the retina, it gets sent into the optic nerve and it gets sent to our brain. And here it is right here. Okay. So this sheep eyeball is actually a little hard to see. I'm going to try my best to show you. So there's a little bunch of cells right there. Okay, this is really hard to see. I hope tomorrow's live will be better. But that is the optic nerve. And that's what sends the light messages to our brain. And our brain then interprets it as the image of the world that we see. And that is the sheep eyeball. Okay, so just to do a quick recap, the cornea is our outer covering that protects our eye, but also refracts light, similar to how telescopes refract or bend light as it enters into our eye. Then we have our iris. Our iris contains the pupil, and the pupil is what lets the light in. So remember that humans can only see the visible light spectrum, which is just a very narrow part of the electromagnetic spectrum, and it lets the light in through our pupil. You'll notice that this one's oval, but in ours, it's just round, okay? Then we have this vitreous humor, and this is clear or transparent to allow light to completely pass through it. That's called transmission. Then we have our lens. This is a convex lens. And convex lens focuses the light inward and bends it in to give us a virtual image. Okay, so that's the lens. It needs to be cleaned up a little bit, I think. So then after the lens, we have the back of our eye, which in humans is completely black because it absorbs light, whereas in a sheep, you get this kind of cool, like iridescent looking stuff called the tapetum that reflects light. Okay, and you can kind of see it glowing in my light here because that reflects light. And that is the eyeball. So I'm going to take off one of my gloves here so I can end the session. So this is a recording that I've done for you. If you would like to catch a live dissection of the sheep eyeball, please make sure to tune in to Ms. DiMaggio's help session teams at 10 o'clock and 2 o'clock. See you guys later. Now go take that quiz on Illuminate. You'll do great.